Okay, so we are going to start 2.6 day 1 today. It is called nonlinear inequalities. Day 2 is also nonlinear inequalities, but I'll just explain the difference between the two really quickly. In day 1, we're talking about polynomial inequalities. So you have done linear inequalities before. So, for example, like y is greater than or equal to 2x plus 6. You've done that before. What we're going to be doing is polynomial inequalities. So these aren't lines that we're graphing, okay? And we're not going to be, in the warm-up we'll graph just so we can understand where our answer comes from, but this does not involve graphing. Go ahead and pause the video and do the opener. Graph that polynomial. Okay, so let's see how you did here. So to find the degree lead coefficient in Y-intercept, I need to know the first term, which wasn't given to me, so I'm going to multiply out the first term. I'm going to do negative 1/2 times x squared times x to the third times x to the first, and that's negative 1/2 x to the second, third, sixth. I counted 2 plus 1 plus 3. Okay, so now I can answer the question, what's the degree? The degree is 6. The lead coefficient's negative 1/2. I also can find the y-intercept. So my y-intercept, remember, is always 0 comma something, and I have to plug in 0 for x to see what I get for y. So I'm going to do that. I'm going to do negative 1/2 times, and then I have 1, 2, 3 places to plug in 0. 0 plus 2 is 2. 2 squared is 4. 0 minus 1 is negative 1. Negative 1 cubed is negative 1. 0 minus 3 is negative 3. Negative 3 to the first power is negative 3. So I can see my answer is going to be negative, or my y-intercept is going to be negative here, because it's a negative times a positive times a negative times a negative. And then you can either do half of 4 is 2, 2 times 3 is 6, or you can do half of 12. All right, next, zeros and their multiplicity. So I have 3 zeros. X equals negative 2, x equals 1, and x equals 3. Their multiplicity, remember the exponent on the factor. So this one is even, because it has a 2 as an exponent. This is odd, and so is this. And then that way I know that it is touching the x-axis here, crossing the x-axis here, and crossing the x-axis here. Okay, let's sketch this function. So I do need to know the end behavior at some point. I'm just going to start graphing the points that I do know. So I know I have a 0 at x equals negative 2, x equals 1, and x equals 3. And I know my y-intercept is 0, negative 6. And let's talk about end behavior. So if you look at here, it's even degree, negative lead coefficient. So my arrows are going to be pointing downward. Okay, so I'm going to start with a downward facing arrow. And then I'm going to see at negative 2, what do? I touch and bounce off of it. And then I have to go through my y-intercept. At 1, I cross. At 3, I cross. And I have to end facing downward. Okay. So what we're talking about today is polynomial inequality. So this is not a polynomial inequality. Let me erase everything. Oops, I didn't need to erase that, but no big deal. This is not a polynomial inequality. That's a polynomial equation because there's an equal sign in it. So if you look at the first example that we're doing, it looks exactly like the warm-up, but it's not y equals, and it's not graph this. It's solve, okay? So we can actually solve that and see what the answer is even before we figure out how to do this algebraically, okay? So if you look at what this is asking you, it says, I want to know where this function is greater than or equal to 0, okay? So what I'm going to do is I'm going to highlight where my function is greater than or equal to 0. So first off, you have to realize where 0 is. I'll put a dashed line there. So here's where 0 is, right? And I want to know where my function is greater than or equal to 0 here. So all of these values are greater than, and then these points right here are where it's equal to, and it's also equal to here. So I could already see what my answer is going to be. My answer is going to be the value of negative 2, and I'm including it in brackets there, union, and then the domain of that next piece is 1 to 3, right? And then there's values at both of those because I want to know where it's equal to 0 also. If it was just greater than, I wouldn't include the negative 2, the 1, or the 3. Okay, so that's going to be the answer, but how do I get that without graphing? Because if you look, there's no graph paper for this. So it says if f of x is a polynomial function, then a polynomial inequality has the general form either that function is less than or equal to 0, less than 0, not equal to 0, greater than or equal to 0, or greater than or 0. The inequality f of x is less than 0 is true when f of x is negative, while f of x is greater to 0 is true when f of x is positive. So if you look right here, this is where my f of x or my y values are positive or my y values are negative. Okay? So by finding the signs of f of x for just one x value on each interval, you can determine on which the intervals the function are positive or negative. We're going to use a Sine chart to do this. Here are the steps you will follow. Okay, so step number 1, you're going to turn the inequality into an equation, and then you're going to solve it. These are what I like to call my critical values, which in this polynomial, they're also your zeros. I want you to realize that. They are also your zeros, but I'm going to call them my critical values. Then you're going to create a Sine chart using the 0/critical values. You have to decide if they're open or closed based on the inequality symbol. Then you're going to test a number in each interval to determine whether the value is positive or negative. And then finally, you're going to write your answer as a solution set. Okay, so in interval notation. All right, so let's see how we do this. We're going to do this problem. We have to get this answer that I have up here. Okay. All right, so it says step number 1 is to make it an equation and then solve it. So this step I usually skip of actually just writing it as an equation, right? Let me do it real quickly though so that you know that's what I'm actually doing. And I'm just changing this to an equal 0 for a second, okay? All right, so now I want to solve this. It's already factored for me, so easy. Just set each factor equal to 0 and solve. I can set -1/2 equal to 0, but I can't solve for x, so that's out. So I'm going to set x plus 2, x minus 1, and x minus 3 equal to 0, so I get 3 critical values, or 3 zeros. X equals -2, x equals 1, and x equals 3. So now what you're going to do is you're going to take those values and you're going to put them on a number line. Okay, so here's my number line. Make sure you put them in order of where they would fall in a number line. So -2 would come first, 1 would come second, and 3 would come third. And they don't have to be properly spaced because you're just using this to help get your answer. All right, now I want to know if I'm including -2, 1, and 3 in my solution set. So if you look at this, I just found out where they're equal to 0. This says greater than or equal to, so I am including those. All right, so I'm including that, including that, including that. So now I want to know if I'm including the values less than -2, in between -2 and 1, in between 1 and 3, or greater than 3. Okay, so this is what a Sine chart is. So what we're going to do is we're going to check a value on each interval. So let's talk about this interval, which I'll highlight really quickly, but then I'm going to erase it in 2 seconds. I need a value on that interval. You can pick any value on. I can pick -1 million if I want, but I'm not going to. I'm going to pick -3. Okay? Could I pick -2.5? Of course you can, but I'm going to pick -3. Oops. All right, now I need a number in the next interval. I need a value on the next interval. So in between -2 and 1, I'm going to do 0 because if wherever 0 is possible, I'm using it. In between 1 and 3, I'll choose 2. And then greater than 3, I'm going to choose 4. Okay, so now what I'm going to do is I'm going to go over my inequality. Okay, not my equation. I'm going to go over to my inequality right here. And I'm going to plug in -3. Okay, all that I need to know is if when I plug in -3, if I get a positive or negative answer. I don't need to know the actual value. Okay, so if you look, no matter what, you're going to have a negative in front from this -1/2. And then I have to plug in -3 into 1, 2, 3 places. So 1, 2, 3 places. All right, so now I just want to know if you get a negative or a positive answer. So if I plug in -3 here, I have -3 plus 2, which is -1. But then I have to square it so it becomes positive. So that's positive. Now I'm going to plug in -3 here. -3 minus 3 is -4. Then I cube it. A negative number cubed is still negative. And then I have -3 minus 3, which is negative. So that now I need to know if I multiply a negative times a positive times a negative times a negative, is that positive or negative? It's negative. So these values are less than 0. Okay, that's what it's telling me. Now I'm going to plug in 0. I get the negative 1/2 no matter what, and then I have 3 places to plug in x. 0 plus 2 is 2. 2 squared is positive. 0 minus 1 is negative 1. Negative 1 cubed is negative. 0 minus 3 is negative. So once again, I have a negative value there. So these are values less than 0. All right, now I'm going to check 2. So I get a negative no matter what in front. All right, so plugging in 2. 2 plus 2 is 4. 4 squared is positive. 2 minus 1 is 1. 1 cubed is positive. 2 minus 3 is negative 1, so that's negative. I almost wrote negative 1. I could keep it there. It doesn't matter. All right, so a negative times a positive times a positive times a negative is a positive. All right, last but not least, I'm going to try 4. I get that negative in front no matter what. 3 places I have to plug it in. 4. Okay, so 4 plus 2 is 6. 6 squared is positive. 4 minus 1 is 3. 3 cubed is positive. 4 minus 3 is positive. So a negative times 3 positives is a negative. And I forgot to put my plus up here because that was positive, and this is negative. So now I want to go back to my inequality. I'm going to say, okay, what was I finding? Was I trying to find values greater than or less than? And I already got the equal to. They're already colored in there. So I need values greater than 0. So that's where my y values are positive. So the last thing I want to do is I want to write this in interval notation. So I need to include this value and then these values. So my answer is negative 2 union and then 1 to 3 including both. And there's your answer. And that's what we said we're going to get. Okay? All right. All right, so what we're going to do now is we're going to try 4 more. They're all a little bit different from each other, but the process, it's the same idea for all of them. Okay. So first thing I do is I make an equation, then find my zeros. So this is already factored. It's already equal to 0. So I'm not going to actually make it an equation. I'm just going to pretend in my head it's an equation. And then I'm going to set each factor equal to 0. So I have x equals 0, x equals 5, and x equals negative 2. Now I'm going to put those numbers on a number line. Negative 2 would come first, then 0, then 5. If I look at my inequality symbol, this is less than, not less than or equal to. So I'm not including the values of 0, 5, and negative 2 in my solution set because that's where they're equal to, and I'm not including equal to. All right, now I have to check a value on each interval. So I'm going to put check over here. And I'm going to check negative 3 because that's less than negative 2. I'm going to check negative 1 because that's in between negative 2 and 0. I'm going to check positive 1 because that's in between 0 and 5. And then I'll check 6. So you could have chose 7 instead of 6 or 12 instead of 6, or you could have chose 2 instead of 1. I just like to think of the smallest number I can think of. Unless it's 0, then I choose 0. Okay. All right, so I have to plug in x 1, 2, 3 places. So I'm going to put 1, 2, 3 places. And I'm going to do this. This is going to be smart. Copy. Delete that right there. And I'm going to paste. What? I thought I copied. Oh, I forgot to go back to it. Paste. 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 See, there are things that this iPad's great for. Okay, so now I'm going to plug in negative 3. And where am I plugging in negative 3? Here, here, and here. All right, so I get negative 3, so it's negative. And then negative 3 minus 5 is negative 8. Negative 8 squared is a positive number. Negative 3 plus 2 is a negative number. So that is going to give me a positive. So anything here is greater than 0. All right, now I'm going to check negative 1. I get negative. Negative 1 minus 5 is negative 6. Negative 6 squared is positive. And then I have negative 1 plus 2, which is a positive. So now I have a negative times a positive, which is a negative. All right, now I'm going to try 1 here. That's positive. 1 minus 4 is negative 4. Negative 4 squared is positive. And then 1 plus 2 is positive. So that's going to be positive. And then plugging in 6, I get positive. 6 minus 5 is 1. 1 squared is positive. 6 plus 2 is positive. So this is positive. And I forgot once again to add them to my sine chart. So I'll do that right now. Not a big deal. All right, so now I have to look at my inequality symbol and it says, wait, did I want values less than 0 or greater than 0? And I look and it says a less than, right? This is less than. So now I want to shade the values that are less than 0. Those are my negative values. That's right there. So now I want to write this in interval notation. These are all values in between -2 and 0, and I'm not including -2, and I'm not including 0. All right, moving on to the next one. So I'm going to pretend it's an equation and I'm going to solve it. So this time it's already equal to 0, which is great, but in order to solve it, it has to be factored, which it's not. So I'm going to have to factor it so I can see the factors so I can find the zeros. So this is factorable. This factors to x plus 4 times x minus 2 and then less than 0. So now you can pretend that's how it started. Okay. All right, so my zeros are, or my critical values are -4 and 2. I'm going to put those on a number line. -4 comes first. 2 comes second. Now I look at my inequality symbol. It's less than, not less than or equal to. So I'm not including the two values where it's equal to. Okay, so now I need to check values. I'm going to check -5 because that's less than -4. I'm going to check 0 because that's in between -4 and 2. And then I'll check 3 because that's greater than 2. All right, I have 2 places that I need to plug in, copy, paste, and paste, that I need to plug in these 3 numbers. So I'm going to start with -5. -5 plus 4 is a negative number. -5 minus 2 is a negative number, so that's positive. Plugging in 0, I get a positive and a negative, so that's negative. Plugging in 3, I get a positive and a positive, so that's positive. So this is plus, minus, plus. I look at my inequality symbol. I want to know where values are less than 0. Those are my negative values, which are right here. I don't know why I used a highlighter. Not a big deal. And now I want to write that in interval notation. So these are values in between -4 and 2, not including -4. Oops, I put an extra negative there. Not including 2. All right, here's my next one. At first glance, it looks like it's factored, but it's not. I can't solve it yet. Okay, like the left side's factored, but what about that 20? So what I'm going to have to do is I'm going to have to expand it, get everything on one side, and then I can factor it. So let's do that. We're going to expand it. Distribute your x. X squared plus x is greater than or equal to 20. Get everything on one side. X squared plus x minus 20 is greater than or equal to 20. And now I can factor it just like the last one. So this factors to x plus 5 times x minus 4 is greater than or equal to 20. I have 2 zeros, x equals -5 and x equals +4. Put those 2 numbers on a number line. -5, 4. I am including them this time because it's greater than or equal to. So the or equal to means includes the ones that are equal to. All right, so now I need to check some values here. So I'll check. A value less than -5 is -6. A value in between -5 and 4, I'm going to choose 0. And then a value greater than 4 is 5. Oh, people always ask. They'll say, so you're checking to see if it's positive or negative. Will you ever get 0? No. These are your zeros. All right? That's what makes it 0. So if you are getting 0, that means that you probably factored wrong. Or your 0 is wrong. Like if it was an x plus 4 and you said 4 is a 0, which it's not. -4 is a 0. Okay, so now I need to plug this in. Where am I plugging it in? I'm going to plug it in right here. Okay, don't plug it in here because then you can't use your positive-negative test. Okay, so I have 2 places to, I can still copy and paste from last time, I think. I have 2 places to plug in x. Okay. All right, so I'm going to start with -6. -6 plus 5 is negative. -6 minus 4 is negative, so that's positive. 0 plus 5 is positive. 0 minus 4 is negative, so that's negative. 5 plus 5 is positive. 5 minus 4 is positive, so that's positive. So this is plus, minus, plus. Now I look to see what I want. I want values greater than or equal to 0. All right, so I want my positive values. So here's my positive values. Here's my positive values. So now I can write my answer in interval notation. So these are values from -infinity to -5 including negative 5, union 4 to infinity, including 4. And there's your solution set. Okay, one more to try here. Similar to the last one, I need to factor it, but in order to try to solve it by factoring, it has to be equal to 0. So I'm going to get everything on one side first, x to the 4th minus 4x squared less than 0, and now I'm going to factor it. There is a GCF of x squared, and then if I factor that out, that's x squared minus 4 is less than 0, but it's still factorable because x squared minus 4 is a difference of squares. So I have x squared times x plus 2 times x minus 2 is less than 0. So I can see 3 zeros here. I got x equals 0, x equals negative 2, and x equals positive 2. I'm going to put those on a number line. Negative 2 comes first, then 0, then positive 2. All right, so it looks like I'm including values less than 0. And once again, let me highlight where I'm looking. I'm looking at this, okay, the factored form where one side's 0. All right, so it's looking for values less than 0, not less than or equal to, so I'm not including these ones where they're equal. And now I need to check some values. Okay, so a value less than negative 2 is negative 3. A value in between negative 2 and 0, negative 1. A value in between 0 and 2, 1. And then a value greater than 2, 3. Also, like if it was a value in between 0 and 1, you could pick a half. It's not, like you can still plug in a half. That's fine. Okay, so I have 1, 2, 3 places to plug in 0. So I'm going to do 1, 2, 3. And then I'll copy that. And then paste. 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 Okay. All right, plugging in negative 3. I have negative 3 squared, which is a positive number. I'm plugging into the highlighted inequality. Negative 3 plus 2, which is negative, and negative 3 minus 2, which is negative. And I put it in the wrong spot. So that was positive, negative, negative, which is a positive number. All right, now I'm going to plug in negative 1. Negative 1 squared is positive. Negative 1 plus 2 is positive, and then negative 1 minus 2 is negative, so that's negative. Plugging in 1, positive, positive, negative, so that's negative. And then plugging in 3, positive, 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 which is positive. So I have positive, negative, negative, positive. All right, now I'm going to look at my inequality symbol here, and its values less than 0, so those are my negative values. So now I'm going to write this as an inequality. Make sure you're not writing values in between negative 2 and 2 because then you're including 0, and 0 is not included in your solution set. So negative 2 to 0, union 0 to 2. That's my solution set. Okay, so the very last set of problems here, it says write a polynomial inequality that has the following solution sets. So I gave you the solution set. You have to give me the inequality. Okay? So how I start this is I say, okay, what does this look like on a number line? Here's negative 6, here's 1. Am I including negative 6 and 1? If you look, I'm not because they're both parentheses. So I'm going to do open circle, open circle. Okay. So now I know that negative 6 is a 0 and I know 1 is a 0. If negative 6 is a 0, I know x plus 6 is a factor. If 1 is a 0, I know x minus 1 is a factor. And then I know there's 0 over here. I just have to know that inequality symbol right there. Okay, that's all I got to know. So what I'm going to do is I'm going to plug in a point and I'm going to test it. I'm going to plug in an x value and I'm going to test it. Now, but first I have to say to myself, is this values in between negative 6 and 1 or is it outside? It's in between, right? So that's what it looks like. So I need to know, are these values positive or negative? If it's positive, then I'm going to say values greater than 0. If it's negative, then I'll say less than, okay? All right, so I need to pick a value there. That's the only place I really need to pick a value. I'm going to pick 0, so I'm going to check. I'm going to check 0 because 0 is in between those two. All right, plugging 0 into this. I got 2 places to plug it in. 0 plus 6 is positive. I just put 6 instead of positive, but it doesn't matter. 0 minus 1 is negative, so that's negative. So these values are negative. So if that's my solution set and they're negative, their value's less than 0. And there's my inequality. You do not have to expand it. You don't have to multiply it out. All right, you can pause the video and try this one on your own and see how you did. All right, if you struggled or if you're just waiting, you can fast forward through this. So this tells me my solution set are values in between negative infinity and 2, so I need a 2 on here, and then 5 to infinity. So I'm including 2 and its values less than that. I'm including 5 and its values greater than that. So 2 is a 0, so x minus 2 is a factor. 5 is a 0, so x minus 5 is a factor. And I know there's 0 over here. I just need to know my inequality. So 2 and 5 are included, so I know it's or equal to. I can do that, right? I just need to know if it's less than or equal to or greater than or equal to. So this is where my solutions are. So I need to pick a value in either of those or even both if I want to do. Find out if they're positive or negative. So a value less than 2, check. I would choose 0. And if instead I picked a value bigger than 5, I'd pick 6. But you can use either one. So if you plug in 0 to your 2 spots, you get negative 2 times negative 5, which is a positive. And if you plug in 6, you get 4 times 1, which is a positive, times a positive, which is a positive. So both of these are positive. And they have to be the same thing, right? So positive values are values greater than or equal to 0.